Okay. All right. Welcome all. Welcome to you online. Online. There's the camera. Welcome to you here in person. Happy Halloween. So this is going to be a pretty casual lunch and learn. The idea of the lunch and learn is for you to have lunch and learn. So pizza's coming. It's not here yet though. If you have followed the tutorials online and gotten Anaconda set up, that's great. If you haven't, that's okay too. Okay, let me see still getting technology worked out, but I think we're good. Okay, so welcome everyone. I'm really glad that you're here. And part of what I want to give you today is some context for where Python fits into your education and data science. So just as you walk in, just grab a seat. So Python is a programming language. That means you can do all sorts of different things in it. People use Python and have used Python for decades to analyze data or things like data science, but also just write computer programs. So some people have written computer programs, for example, to like go through files on a computer and maybe like delete them. Other people have written Python computer programs to make interactive interfaces. Some people use Python to do quantitative like simulation, like to simulate physical phenomena, things like that. And other people use Python to just scrape the web for information, like to access a web page, take out the HTML or whatever is kind of like the beefy content of the web page and look for something in particular, like maybe a price. So Python is very general. Oh, let's not forget computer networking, which Python is used very much for setting up connections between computers. So Python is a general purpose programming language. It's not just a data science tool. All right, so just in a nutshell for people on Zoom who didn't get to hear any of that, basically what I was saying is Python is a general purpose tool with a gigantic community of people doing enormous numbers of things, many of which have nothing to do with data science, that you can then leverage all of their work in building modules. You can download those modules and install them and then use them to do things related to your data science that aren't specifically data science in addition to the data science. And as some examples I gave were reading some weird file format that nobody except like a few people know how to read, or connecting to a remote server and accessing that data, for example, from your corporate server that has a specific kind of connection protocol that you then want to wrap into your data analysis. And then the example that I was starting to talk about, and hopefully the audio hasn't left yet. Yeah. The example I was starting to talk about was a John Deere data set that you could create yourself by connecting to John Deere's web page, looking at the structure of the web page, looking at the HTML, like you're getting really like deep into the web underlying structure, and then extracting data like model, price, quantity available. And then there's actually web scraping tools and module that you can then change the web page and look at a different tractor, change the web page and look at a different tractor. And rather than doing this all by hand, you could actually write Python programs to do this for you, which I did, and I created a nice little John Deere data set that wouldn't be available from John Deere because they don't just give you their price data as a data set unless you're like a corporate partner or something. But you might want to create that data set for your own reasons. And then if you looked at the Internet Archive, you could find old pages of John Deere and look at how the prices have changed over time, which would be an interesting data analysis project that would require something like Python to actually build your data set. Okay, so that's the motivation for learning Python. Yeah, Isaac?
Oh, no, just cheering.
Just cheering, go Python. So, so the context then is that Python is just one tool for the job. It's not the best tool for the job in every case. And I was talking about earlier, before the session started, is where does Python fit in with all these other tools? An analogy that I used was, let's say your data science project and your goals, the questions that you're asking of the data would be like an analogy to washing a window. And you know that your goal is to get the window clean. But there's not just one way to do it. There's a lot of different ways to clean a window. You might have a paper towel and some Windex, and that's how you clean the window. That works fine. It gets the job done. You might, on the other hand, have a squeegee, and that works too. Or you may be in charge of cleaning a whole skyscraper full of windows. And then maybe the paper towel and Windex thing isn't going to work for you because you need to be able to automate it a little bit more. That's where something like Python versus something like Excel might come in. Because Excel would be a great tool for the job for cleaning your house windows and just everyday cleaning of windows. But maybe it's not the right tool for the job when you're dealing with enormous skyscrapers. In which case you bring in all these other tools that are much more complex. Using something like Python means you don't have to build those tools yourself. You can just go get them and start using them. On the other hand, the learning curve for cleaning a skyscraper is pretty high. Similarly, for Python, you know, it's a little bit of more of a learning curve to get into than just something like Excel or Tableau, which is targeted more at a general like business or just general audience, people that really aren't interested in learning about computer programming. Okay, so is there one best tool for the job? No, there's many tools that can be used, and they can all get you clean windows. Okay, yeah, so we just had pizza get in, so we're gonna take a break. In case you're curious what we're gonna do next, when you get done with your break, I'm gonna start showing you how you would actually look at some data in Python. Raise your hand, and same in Zoom, if you do not have access to like a Jupyter notebook right now. Yeah, you don't. Raise your hand if you don't have access right now to a Jupyter notebook. Oh, good question. So maybe you don't. Jupyter Notebook is the way that we're going to use Python today. Yeah? That's not going to feel the same as what I'm going to show you, but there's a lot of different ways to get the job done. What I was going to offer, though, is Steven and I have just been trying out something that we're working on for our campus, trying to get like cloud access that's also campus related. So I'll post a link in Zoom if you want to access things through the cloud. But for everyone else, I'm going to show my screen / share my screen and walk you through a little bit of getting started with Python for data science. So let me figure in Zoom. I don't know. That's not for me. Okay. All right, people on Zoom, can you see my screen?
Yes.
Just see Windows?
Yes, I can see
Big
it.
old Windows icon? Okay, good. And y'all can obviously see it. Okay. So the way I walked you through on the tutorial is just one of many ways to get involved with Python for data science. However, most people that I know who are using Python for data science are using the tools at least related to Jupyter Notebook, which is just one way to access Python. The idea of a Jupyter Notebook or a notebook in general, is that you can mix some code, like Python code, with well-formatted text. And that's a powerful combination when you're exploring things and you want to document as you go. So you don't have to document in monospaced font. You can document in like bold and put in hyperlinks and things like that. So to open up Jupyter Notebook, if you follow the tutorial, then you can just do it as simply as just opening up Jupyter Notebook from here or from the launcher for Anaconda. You can just open up Jupyter Notebook. I already did that, so I already have it open. This is like kind of like what you'd see when you open up Jupyter Notebook, maybe just like your home folders on your computer. And this is kind of an old school way of accessing your Jupyter Notebooks. The reason I'm taking you through it is it's also like kind of the simplest, most universal way. When you use other cloud services, or even sometimes on your home computer, you might use something called like Jupyter Lab or Jupyter Hub. These are all kind of just ways to get to Jupyter Notebooks. Just like a Jupyter Notebook is just one way to get to Python. So I'm not like tied to any given way to get to a Jupyter Notebook, but this is one way. It's just to launch Jupyter Notebook. And then this is actually all your folders on your computer. So in my documents, I have a folder called Plot-A-Thon. In there, I've downloaded some data, which I'd like you to also download at least one of them. And so getting a data set is not too hard. There's a lot of different data sets you can explore, but I wanted to explore something for Halloween since it's Halloween. So to get the data set, I just searched pumpkin data set, or Kaggle is one webpage where they host a lot of data sets for free. And I went ahead and found the year of pumpkin prices, and I downloaded this data set. You'll have to sign up for an account, which is free, to actually do the download. Once you do the download, you'll get a file called like archive.zip. You'll just need to unzip that into the folder that you made for this demo. So for example, if I look in my downloads, I've got archive.zip. I would just kind of move it over into my documents, into my Plot-A-Thon folder, and paste it here, and then extract all or unzip here, things like that. However you like to unzip folders is fine. And then you'll get all these files that come out. What this is this data set has pumpkin sales from 2016 to 2017 in 13 cities, and each city has its own file. So for example, if we were to open up one of these in Excel, we could look at what's inside. What city would you like to see? Los Angeles? Okay, so if we open up Los Angeles in Excel, we can see that this data is maybe not what you would have expected, because we know that pumpkins don't cost $120, at least not the kind we get. But the reason for that is because this is like a corporate data set. This is not something that like maybe is based on the way that you would think about it. It's for 24-inch bins of pumpkins. So when people buy pumpkins at the grocery store, they buy individual pumpkins. But if you just buy pumpkins as a corporation, you just buy bins of pumpkins. So that's kind of like something to think about here, is that whether or not you even want to analyze a data set, you might want to explore what's actually in the data before you start analyzing it, and then make that call. So anyway, so some of the prices are per pound, some are per bin. This is basically going to be a pretty messy data set. But what I'm going to show you how to do is just load it in, and we're not even going to do much analysis on it. And then we're going to open up a candy data set that's a little more user-friendly. So if you want to get the Candy dataset downloaded, it's also on Kaggle. So you might as well just knock that out while you're on. As you can see, I just searched Candy dataset, and I just downloaded this dataset. Click download. Once again, just unzip the archive. And when you do that, like let's see, take it, copy it over, put it into your Plot-A-Thon folder, and what you'll get out there is candydata.csv. And then the last data set that I want you to download is about Halloween costumes. So just search costumes on Kaggle. And this is perfectly fine to download. And when you download this data set and do the same thing of unzipping it, you'll get costumes on Amazon. These are 3 different data sets. They're very different. They're all Halloween. So when you get to Plot-A-Thon, if you decide to compete, you're going to get a data set and you don't know what it is until you're there. So one of the things you'll need to be ready to do is to dig into different types of data set. So if you want to like warm up or build your skills, you might just want to explore several data sets on Kaggle or other kinds of data sources so that you get a sense of the good, the bad, and the ugly as far as data sets. Like you might find that some data sets are harder to analyze than others, or even just clean. Okay, so back in Jupyter Notebook. Nope, that's an old one. Okay. Once you have your folder full of stuff, you'll want to make a new Jupyter Notebook in that folder. And the way you do that is you go to New Notebook, like that. What that does, you see it just popped up. It made a new file. This file is called untitled.ipynb. That stands for IPython Notebook, and it's the file format of Jupyter Notebooks. But you probably don't want to have it called untitled, so you could call it like Halloween. And that will change the file name over here, as you can see. Okay. I want to pause for questions. Questions online? Okay. All right, so we've gotten through these steps of downloading some data sets. Those are the same no matter what you're going to use to analyze them. We've also gotten through the steps of opening up a new Python notebook, which is something unique to if you're doing data science with Python. Now I'm going to show you how to load in some of the modules, which is the name for the pre-written portions of analysis that other people have already done to help you do your own analysis. Well, you all look really busy, so I'm thinking I'm going to give you one more second to catch up. Yeah. Well, it's your choice, but I would suggest it just for the next hour. Yeah. So one was called costumes. You know, this might be an example of using Markdown to document what we're doing. So in Jupyter Notebook, there's all sorts of hotkeys. If you press H, you can see all of them. Yeah, just type H. And there's a concept of command mode and edit mode. Command mode is blue. Edit mode is green. And so right now I'm in command mode, but if I double click here, I'm in edit mode. See how it turned green? blue, green, blue, green. So when I'm in command mode, I get to use the command mode hotkeys, which are up here. When I'm in edit mode, I get to use the edit mode hotkeys, which are down here. You can also just use the stuff up here, which oftentimes tells you what the shortcut is as well. Like cut is X, copy is C, delete is DD. So if I want to delete the cell, well, I can't delete my only cell. But if I wanted to delete this cell, DD and it's gone. If I wanted to insert a cell above, I could just press in command mode. So hotkeys are nice. If you are using a lot of Python, you'll end up learning the hotkeys because it makes life faster. But if you're just doing it here and there, you might just look it up every time in the file menu. I mean, in the toolbar up here. Okay, so I can change this cell to Markdown. Markdown is the same format that you use on something like Wikipedia. It has like some standard syntax. The easiest thing to do is just type some words in. And then to make it look pretty, do Shift Enter or Run. And then it writes it in pretty words instead of weird monospace font. And then you're back to a cell of Python code. You can also do syntax, though, like headers and tables and all sorts of things that you would do in like Microsoft Word. But you do it with this syntax called Markdown. And so like a header for a title is one hash and then a space. Okay, yeah. No, it's called Markdown. Yeah. So you can look up Markdown and find all sorts of resources if you want to. What is Markdown? Why use Markdown? Do. And so anytime you go to Wikipedia, let's see. Like, let's say I want, oh, like an advertisement. Oh, well, let's fix that. If you wanted to edit Wikipedia, it is in Markdown. So like, see how this looks? This is Markdown. So yeah. I don't know. Like, let's see if this works. We'll just like, it's probably not going to work great, but we could just turn this to Markdown and paste some of Wikipedia in here. This looks like this whole reference thing is probably not going to work, so I'm just going to delete that whole part. Okay, didn't work great actually. This is special Markdown syntax for Wikipedia that lets you link to other articles on Wikipedia. So that wasn't super helpful. Anyway, that is not what I meant to focus on. Yeah. Oh, if you double click on it, it opens up edit mode, which is blue. And then if you run it, it turns it back into the display. Is that what you were wondering about? Not for this one. Oh. You have to change this. And of course, there's hotkeys. Like you can just press M and then it turns it into Markdown if you're in command mode. Okay, this is totally, I don't want to spend so much time on the Markdown side. So let's get into the Python. Some of you may have literally never opened up any of the stuff from the tutorials. So let's just give you a quick win. So in Python, if you want to make something print, you use a function or basically a way of telling the computer what to do called print. And so if you type this, we can get it to print out hello ghosts. So give that a try. You'll notice that I didn't click run because I just did Shift Enter, which is the hotkey for run. Okay. All right. So I was talking about how Python has all these modules. And what I said is that people have done a lot of work to create everything under the sun that you can think of in Python because it has a large user community. Just like if you're going to modify your car, like you might want to get a car that's part of the community cars, not like some weird car from, you know, somewhere that people haven't heard of, because you want to actually be able to like talk with people that have modified their cars and get their advice at the local car meetup. Similarly, if you use a programming language that is equally capable to Python, but that does not have the same user community, you will not get the benefit of all those people that built stuff for it. Python has a huge user community, and so people have built things for analyzing tables of data, which is what we want to do. And one of the best tools for that in Python that you can download is called Pandas. So Pandas is a module that is built by the community that is dedicated towards opening data files, slicing them, cleaning them, plotting them, like getting analysis done with them. And so it's a great tool for data science. So if we want to use that tool, luckily it comes with Anaconda. All we have to do is tell our computer code that we want to activate that component. And the way you do that is through the Python import statement. So if you do import pandas, and oftentimes people will give it a short name like PD so that they don't have to type pandas out a lot. So this is a nickname for pandas. You could call this anything you want. You could call it koala, like if you want to call pandas koala. But a lot of people just call it PD because that's really short. It's like 2 letters, but it's long enough for you to recognize that it means pandas. Okay. And you can see now the power of having a notebook versus just having computer code like in Visual Studio or something. Like you have the actual comments here. Now that I have pandas, I can use anything that is in the module called pandas. But since you don't already know how to use pandas, you don't know what's in pandas. You don't know what pandas can do. So the first thing you might do is like search the web, like pandas open CSV. That'll totally get you there. These are just like random web pages that might help you, but they're not the definitive source. There is one search result, though, that is the definitive source. That's this one, because it's by the people that made pandas. So this is the next kind of lesson that I want to emphasize, which is you can find stuff online, but it can be very confusing because you might get little bits of information here and there. It's a great way to get started. But when you want to know what something is and like learn it for real, then you want to go find the official reference. And every single one of those modules that you can import has one of these, official reference. The official reference tells you everything you can do with that module. So if it's not in there, you can't do it. Whereas on the web search, you can find all sorts of stuff, but you might wonder if something's possible and if you just need to search harder. Okay, so we got a hint when we searched pandas OpenCSV, that maybe we want to use that function called read_CSV, because it looks like it reads comma separated values file into a data frame, which is the equivalent of a table in Excel or Tableau or R. So you might just follow some tutorials on your own time, but I'm just going to show you how this is the official reference that you can always turn to when you need the definitive answer. And so you can search within that for the function you were looking for. And now this is overwhelming, perhaps, but it is everything. You don't have to wonder if there's another option you didn't know about. What you're looking at is the syntax for calling the function called read_CSV. When you see something there without an equal sign, that means it's required. When you see something there that's with an equal sign, that means it's optional. So if you don't put it there, that's fine. So it looks like there's only one thing that's required, which is a file name. And you can look down here for more information. It should be a data type called a string. If you don't know what that is, it's basically just saying it's like letters, or a string of letters, rather than like a number. Oh man, we're gonna have to go down a different road for that. But there's different types of data, and one of them is called a string of letters. So you could do a URL. Looks like you can do just like the file name. There's lots of different ways. So even though there's all these other options, that's the only one you have to put in. And then all of these are just for fun, like if you want to. But these are the definitive definitions of what these mean. So if you see in a tutorial, someone like uses the function and then they use the option decimal equals something, that website might not have any context of like what that even meant, but you can go look it up and find out. It's the character to recognize it as a decimal point. So it turns out in Europe, they use a comma, instead of a point. And then all the way at the bottom, you'll see what it gives you back after you run the function. This is going to give you back something called a data frame, which is the basic unit of a table in pandas. All right, so let's try it out. We're going to do pandas.readCSV. We're just going to call it PD because we nicknamed it. And then our file name for this first expiration we agreed is Los Angeles. So we'll need to copy and paste that full file name and put it in quotes. And in Python, you want to put what you want to save the value into on the left-hand side and what you want the value to be on the right-hand side of the equal sign. So we can call this like LA because it's LA data. And now that I feel like this is fine, I'm going to press run. Anticlimactically, it didn't print anything out. But if I then look at what's inside just by typing LA, I can see. So this is what it loaded in. So see if you can get that to work on yours. And if you have a question online, now's a good time. Yeah, Isaac.
Do you have to create like a path for it, or does it just figure out what, like, just off the file?
Well, the whole thing here is that I made a Halloween file in the same folder as my Los Angeles file. So it just looks in the folder that you're in. It's a good question. So the key here is that if I look, I have a folder called Plot-A-Thon, and it has Halloween.ipython notebook and LA. Okay. If you wanted to do something more advanced, you could. But for people that are just beginning with Python, probably better. Yes. It's saying that you don't have that file. Is that in the same folder as this? So if you got a file not found error, it might mean that that file is not in the folder. Okay. Is it the .csv at the end?
Find the folder that I downloaded. So how can I find?
Did you make a folder?
I don't think.
You can just make a folder wherever you want and then navigate to it through that browser. Yeah. Yeah.
And I put datasets there.
Okay.
And then in here in the Jupyter, like it gave me, like I guess it would have took all my things. But then I went to plot here.
I think it
And like
might be.
this-
Yeah. They're not unzipped yet, I think.
Instead of the.
They look like they're still zipped up. Well, oh, they're in folders.
Is that not right?
It's not like wrong, but if you go back to your
Oh, 'cause it-
web regular like Mac Finder,
I don't know, sometimes.
copy
what
all that
I've
stuff
heard is they-
up to
this
the level
backslash
above it.
This backslash.
Yeah. Like see how it's like in a subfolder?
That's one thing
Just
that
like
sometimes works.
copy everything in that folder up one level. So that it's all in
It's
the
happened to me
main
before,
folder
and
instead of in a
It's like
subfolder.
Crash, and I'm just like, what the heck's going on?
Yeah, but move all this stuff. Yeah. If you have a question online, just unmute because I won't be able to see the chat quite as well as I can hear you. All right, how's it going? Reading a data set?
I just forgot where I put my folder.
Yeah, it happens, definitely.
Changing the file name, like, you know, this is fine.
It's probably because you already have stuff in that folder that's open. Like it's Halloween in that folder. If you want to change the folder name, maybe close Halloween and then try again. Maybe just make a new folder. It's usually because something's open in that folder, like maybe it's this window. Like something's saying like you can't just rename the folder. Yeah.
So when you download the file, it's a zip folder, right? So how do you make it the Python file? We have to confirm.
Unzip the folder and just put all the contents into your main folder. Let me show you. I see a lot of people with trouble on getting the files into the right folder. So let me like walk you through that. So let's say I started from scratch. I'm not gonna do it just in my documents, and I'm like, my Halloween exploration. So I made a new folder in my documents. There's nothing in the folder, right? But that's okay, I'm gonna put some stuff in there. So I go to Kaggle. I don't know where. Maybe I closed it. And I'm gonna download my data. Download. Here it is. It's my data. There it is. That's my data. So I'm gonna cut it and paste it in my new folder. And then if you're in Windows, you could just do extract all. You can put them wherever you want. They went into this new folder. I'm gonna delete the zip file. and they're in here now. But I would rather just have them in my Halloween folder, so I'll just cut and paste them up here. Okay, so now I have my files where I want them. Then I go into Jupyter Notebook. I got into my home folder, but I know that my actual folder I'm working in is in Documents. So I'll go into Documents, go into Halloween Expiration, make a new notebook there, and that's how I would get started. Okay, so that's how you get from 0 to where we're at. Hopefully that helps a little if you were stuck on that step. I see what's going on there. Did it work? Okay. Yeah, that's weird. I don't know. But can you just start Jupyter again? I'm going to take this opportunity to talk about pros and cons of doing things on your computer versus in the cloud. So the reason that I had you go through the steps of actually installing Anaconda and Jupyter Notebook and all that stuff on your personal computer, when there's plenty of places you can do this online in the cloud, is for one reason only, which is if you're in a business setting, you may not trust putting your documents into the cloud. And I just wanted you to know that you can run it all on your own computer if you want to. So that's the main reason that you would want to do something locally on your computer in 2023 is privacy. So if you're using something like Google Colab, you know, like your business might not be okay with you uploading their like most personally identifiable information data sets into Google Colab. Similarly, if you're using some other resource. But with your own computer, your work computer, something that's fair game. You can analyze personally identifiable information all you want because it's not leaving your computer. Okay, so that's the one reason. On the other hand, for the Plot-A-Thon, you can do it however you want. If you want to use an online Jupyter Notebook that's in the cloud rather than running your own, that's fine. Because there's no personally identifiable information in Plot-A-Thon. Yeah. That's true.
This was done by.
Okay, so raise your hand if you got to this point. Okay, so like 50%. All right, so not everyone. I'm going to show you a couple quick commands, and then I'm going to circle back to how you could do this a totally different way. So let's do a couple quick commands. So this object that we've created, if you want to know what it is, you can just do type. It's kind of like the print function, and then you put the object in there. And here we see it's a data frame, just like we expected because we read the documentation for read CSV. A data frame in Python looks like comes from pandas. So it's another thing that came with pandas. So if we want to find the definitive reference for what you can do with the data frame, where do you think you should look? On python.org? Is that the definitive reference? Is it W3 schools? Yeah, it's Pandas. Pandas website. That's right. Okay. Because these are the people that made Pandas. And they have their definitive API reference. And so if you make this smaller, there's actually a whole section for a data frame. There's so many things you can do with the data frame that they gave it their own section. These are all things you can do with the data frame. So we can do any of these with LA. It's way more than you wanted to know, right? But if you wonder if it's possible, you'll know where to find out. And when you see stuff online and it gives you kind of like ideas of what to do, you can dig deeper using the actual reference. So one of the ones that I find very helpful is called info. And basically it just prints a summary of the data frame. So the way you would use this is you have your data frame and then you just do .info with parentheses. And there's actually all sorts of options here, but none of them are required. You can tell they're not required because they have an equal sign. So if it's required, it would be at the very beginning and have no equal sign like that file path one. So let's give it a try. Just like that. That's how you would call it if you don't worry about any arguments. And it'll print this out. This is kind of a summary of the data set. We have 25 different columns. It's a lot of columns. But a lot of the columns don't have many that are non-null. Null means like not existing, like null, like nothing. So this is good to know because like if you scroll through the data set by eye, you could see some of this, but this is a summary. And what this is saying is commodity name, there are 62 entries, all 62 have an entry. But for subvariety of pumpkin, only 6 actually have an entry. The rest are all blank. And for condition and quality and appearance and storage and crop, there's actually no entries at all. So those columns might as well not be there as far as we're concerned. The reason this data set has all these columns is because it comes from a larger data set. And the larger data set might have entries in those columns. So immediately looking at this, you can see you're going to have some trouble analyzing on some of these columns because a lot of the data is missing. So this comes back to like data cleaning. But you can also do data cleaning with pandas. For example, you could get rid of all the data that doesn't have an origin district. Or you could get rid of all the data that doesn't have a unit of sale very easily with conditional statements. For example, there's one data frame item that's kind of not nice. And this is almost just like an exploration because there's so many different things you can do. But let's go back to data frame. NaN stands for not a number. And there's a whole section on dealing with missing data. You can do any of these methods. So let's say I just wanted to remove the missing values, just like get rid of them. This might be a good function for that. To use it, you'll need to read the documentation to understand like what it does. But basically, you're going to drop either rows or columns which contain missing values. You know what? Let's just get rid of all those columns that don't actually have anything in them. Or let's just get rid of all the columns that have anything missing. So if we want to do that, we can put in the axis equals columns. And we'll drop it if any of them have missing data, which is the default. So we don't need to worry about anything except saying that we want to drop columns. Okay. Okay, so what this has done is we just got rid of like 10 of our columns. We now only have 11 columns. We got rid of all those silly columns that had missing values. So that's kind of an extreme form of data cleaning where you're like, if it has any missing values, I don't want it. But it is one form of data cleaning. It is the kind of thing that Python's really good at. So we just got rid of 10 columns in our data set. That would have been annoying to do by hand. And so now we have a data set that only has columns that are filled. So that's good. All right, so the lesson there wasn't about how to do any of these functions. Who wants to try to say what I might have been trying to teach there? And then I'll let you know if you're on the right track. So what do you think I was just trying to teach? This is a lunch and learn. So you're supposed to learn. So what was I trying to teach you? Need a volunteer. Okay, what's your name? Okay, what do you think I was trying to teach you? Oh, okay. All right. That was true, but tautology. Yeah. What was I trying to teach, Isaac?
You were trying to show us how to get rid of problematic data, kind of like clean data.
Yeah, that's interesting because I can see how you got there, but actually that's not what I was trying to teach you.
How to find information, solve problems.
Yes, I was trying to teach you how to use what? Yeah, I was trying to teach you how to use the resources that are the definitive resource. It's like I taught you about a dictionary so that you can look up words. So now, when you're exploring things on Google and following tutorials and you run into parts of it that you don't understand, you don't have to just search that on Google. You can go to the source. And the source is the package that it was created with. There's something else important that I showed you, which is how to find out what you're dealing with. It was subtle, but this was important. If you have some kind of object and you want to know what type of object it is, you can find out, and that will tell you where to look on the official documentation for what is capable. How would I just randomly know that there was a drop NA function that I could use on LA, which is the output of a read CSV? I wouldn't just know that. That's crazy. I have to understand what LA is. As far as Python's concerned, it's a pandas dot blah, blah, blah data frame. So I go to Panda's website, I find their official documentation, and I find the data frame entry, and then a whole world of options is opened up. This is general purpose information. You can apply this to anything you're working through on a tutorial in Python, because everything in Python has a type. And that type is defined somewhere. Some things in Python are built into Python. Most things are imported through modules. All right, so that's what I was trying to teach you. All right, so we still got 15 minutes. Thank you though for the applause. But we're not quite done yet. Okay, I told you I'd show you a couple functions. So I was going to do this, and then I realized it was a lot harder than I realized. So this is useful to just look at. Don't try to copy this right now, just look at it. This is a typical start of a program in Python where I would start out by importing a bunch of libraries that I might need. So here, I wanted to show you a picture of a witch hat. So I imported an image processing library. I also wanted to get the witch hat from the internet. So I imported a URL retrieval library that lets you download files. And to get ready for data science, I wanted to import plotting libraries. This is something called matplotlib or matrix plotting library or something. I wanted to have retina display because I wanted my graphics to look awesome. I wanted to import a library called numeric Python or NumPy, which is good for cranking through large quantities of data. I wanted to bring in Python pandas, which we just talked about. I also wanted to bring in a beautiful data visualizer called Seaborn, which makes beautiful graphs, and set the theme to the default. And then I wanted to bring in more specific module from within matplotlib called pyplot. Wow, that's a lot of stuff, right? And I'll post this. You don't have to take a picture. That would be a lot to retype out. Not only that, I wanted to set the dots per inch of my figures. Anyway, all sorts of customization and stuff. And then I wanted to show you the witch hat. So what I did is I created a variable called imweb, which was my way of saying this is going to be the web hyperlink. And I copied a hyperlink to a picture online. And then I downloaded it to halloween.png, which is now in this folder. And then I used some Python syntax to open the image using the image processing library called pill, and used matplotlib to show that picture, and turned off the axes because we don't need axes for a picture. That would be silly to have like an XY axis. So even though this turned out to be more complicated than I wanted to walk you through actually doing yourself today, I think this shows why Python's pretty amazing. Because Python, it's like you grab whatever you need and use it. I wanted to show pictures. I wanted to download files. And I wanted to have like retina display. I just got everything I needed together into my like toolkit and did what I needed to do. I didn't need to have like 3 different steps like you would maybe in a, no, we're not competing with C in this room. No, like what you might need to do if you wanted to do this in Microsoft Word. If you wanted to do this in Microsoft Word, you would go find the picture, you'd right click, you'd do save as image or whatever. You'd save it onto your computer to a folder. Then you'd like open it up and copy it into Microsoft Word. And that would do the same thing. But this is all automated. I can replace this URL with anything I want. So I could make a giant data set full of picture URLs and do something to all the pictures. Like put a big watermark over them. I don't know. I don't know why you'd want to do the same analysis on a bunch of pictures from the internet, but maybe you would. So sure. Yeah. So with Python, it's all there that you can actually automate it with huge data sets. So in Plot-A-Thon, we're not going to really feel the full power of Python, just to be frank. We are probably going to have a data set that's accessible to the Excel teams and and so that means it's going to be limited to a certain degree as far as file size, number of rows, things like that, so that it's manageable within Excel. But Python doesn't have that kind of limit. You can analyze enormous data sets and use algorithmic analysis, writing computer programs to explore it. As you saw with the drop columns, I didn't have to delete any columns. I just dropped. Yeah.
Is there a source to find the libraries?
Yeah, why don't I just tell you about some of the key ones? And I'll use the whiteboard. I did this last year too, and I thought maybe some people already watched it. So I tried to make this demo a little different than last year. So the last one can be complementary. But Python. Oh, I know what to do over here. Hold on. Yeah, okay. I did it. Zoom. Okay, so we got Python is the programming language. Within the world of Python, people have created modules. One of the most foundational modules for data analysis is called NumPy, which is numeric Python. As you can imagine, when you're doing statistics or other kinds of data analysis, you need something that can work with large quantities of numbers. That's why numeric Python is a good foundation on which to build. So another tool that then is built from NumPy would be pandas. Pandas can use NumPy under the hood, and it actually is built out of both NumPy and Python stuff. So you end up needing NumPy to use pandas, but when you download pandas, it'll just make sure it's installed. And then on top of something like pandas, there's data visualization, which is like, how do you make those beautiful graphics? Something like Seaborn is a data analysis visualization package. But also out of NumPy, we have matplotlib, and that as well was required to make Seaborn. So NumPy is kind of like, Python's at the bottom of the hierarchy. Like, you need it to do anything in Python, obviously, because it's not in Python if it doesn't have Python involved. Then NumPy is one of the kind of like things that were built on top of Python that's super powerful. Matplotlib is another thing built on top of both NumPy and Python. Pandas is built on top of NumPy and Python, and sometimes Matplotlib. And then Seaborn is built on both of these two. There's lots of other cool packages. Like if you want to do advanced statistics, you might want something called SciPy or stats. And then there's tons of other libraries. But these are a few you might be particularly interested in for data science. So where do you think you find the definitive reference for these? Is it W3 schools? No. There's nothing wrong with reading that web content. Is this Stack Overflow? Is like, it's kind of the reference? No. Okay, it's the webpage of the thing. So, for example, let me share the screen with the Zoom. Okay. NumPy. If you want to get the definitive reference, go to documentation, API reference. This is just like the other one. So just like the other one, I can search it. So if I want to know what this object is that I found, I could find it here. Okay, next. We did pandas. Let's do Seaborn. So you have your like intro tutorials and stuff, but then when it gets down to it, you want to go to the API, which is the definitive reference for everything. And there you can find all the details, for example, for making a bar plot. Look, this looks familiar, right? This is like that other nonsense that we were looking at in pandas. Looks like there's no required options. See, data is optional. X is optional. Y is optional. Q is optional. So then you look at all your options. If you want to use them, you use them. If you don't, you don't. And then it returns a matplotlib axis. Well, what's a matplotlib axis? Where do you think the definitive reference for a matplotlib axis is? Yeah, exactly. Once again, going to the definitive reference. And in this case, I want this. Now I can find out if I use Seaborn and it gives me back a matplotlib axis, which I could find out by doing like type on the object. All the methods I can call. There's a lot actually. I can do a lot with a matplotlib axis. So that's good to know. So feel free to Google stuff and get ideas. But then when you want to get everything sorted out, go to the definitive reference. There is so much out there in Python. You will never learn all that there is to learn in all the modules of Python. But that's kind of the joy of it too, is that there's all sorts of things you can download as add-ons. All right, questions from online, from in person? Yeah. Modules. Yeah.
So they're not considered packages.
That's all in the same world of things.
Okay.
Yeah. Yeah. So what's nice is Anaconda that you downloaded came with all of these already. So you didn't have to install them. That's why I had you download Anaconda. If you just downloaded Python, you'd have to install all these. Yeah.
Is there any other resource or text you would recommend to, in particular, like applying like statistical data to Python?
Ooh, statistics. If you want to go down the rabbit, like if you want to go hardcore statistics, in my book, you can't get better than scipy.stats. There's just so many cool things in here. Like more than you want to see. So if you're trying to do R type stuff, R is known for advanced statistical analysis, and you want to do it in Python, you're going to want to get into a module like this. It stands for scientific Python, SciPy. I like it though. Just like NumPy is a name for numeric Python, SciPy is scientific Python. Yeah. Oh yeah, see, here they're even calling them packages. So you're right. So it can be called package. Look, see, other by other packages. Yeah, they're modules. And packages. So look, so here they're even saying we're not going to even try to cover all this stuff. You need to go to other web pages if you want to learn about it all. Oh, and if you just want to do R and Python at the same time, that might be like a special crossover for Plot-A-Thon, like compete in both areas or something. I don't think that's allowed, but okay, I think we are at the end of the Plot-A-Thon. So we're at the end of the Lunch and Learn. So thank you all for coming today. I hope you enjoyed it. Feel free to grab some more pizza on your way out, and I'll see you at Plot-A-Thon 2024.